Of all the sciences cultivated by mankind, astronomy is acknowledged to be, and undoubtedly is, the most sublime, the most interesting, and the most useful. For by knowledge derived from this science, not only the bulk of the earth is discovered, but our very faculties are enlarged with the grandeur of the ideas it conveys, our minds exalted above their low, contracted prejudices. James Ferguson, 1757. Long before anyone knew that the universe had a beginning, before we knew that the nearest large galaxy lies 2 million light years from Earth, before we knew how stars work or whether atoms exist, James Ferguson's enthusiastic introduction to his favorite science rang true. Yet his words, apart from their 18th century flourish, could have been written yesterday. But who gets to think that way? Who gets to celebrate this cosmic view of life? Not the migrant farm worker, not the sweatshop worker, certainly not the homeless person rummaging through the trash for food. You need the luxury of time not spent on mere survival. You need to live in a nation whose government values the search to understand humanity's place in the universe. You need a society in which intellectual pursuit can take you to the frontiers of discovery, and in which news of your discoveries can be routinely disseminated. By those measures, most citizens of industrialized nations do quite well. Yet, the cosmic view comes with a hidden cost. When I travel thousands of miles to spend a few moments in the fast-moving shadow of the moon during a total solar eclipse, sometimes I lose sight of Earth. When I pause and reflect on our expanding universe, with its galaxies hurtling away from one another, embedded within the ever-stretching four-dimensional fabric of space and time, sometimes I forget that uncounted people walk this earth without food or shelter, and that children are disproportionately represented among them. When I pore over the data that establish the mysterious presence of dark matter and dark energy throughout the universe, sometimes I forget that every day, every 24-hour rotation of Earth, people kill and get killed in the name of someone else's conception of God, and that some people who do not kill in the name of God kill in the name of needs or wants of political dogma. When I track the orbits of asteroids, comets, and planets, each one a pirouetting dancer in a cosmic ballet, choreographed by the forces of gravity, sometimes I forget that too many people act in wanton disregard for the delicate interplay of Earth's atmosphere, oceans, and land, with consequences that our children and our children's children will witness and pay for with their health and well-being. And sometimes I forget that powerful people rarely do all they can to help those who cannot help themselves. I occasionally forget these things because however big the world is, in our hearts, our minds, and our outsized digital maps, the universe is even bigger. A depressing thought to some, but a liberating thought to me. Consider an adult who tends to the traumas of a child: spilled milk, a broken toy, a scraped knee. As adults, we know that kids have no clue of what constitutes a genuine problem because inexperience greatly limits their childhood perspective. Children do not yet know that the world doesn't revolve around them. As grown-ups, dare we admit to ourselves that we, too, have a collective immaturity of view? Dare we admit that our thoughts and behaviors spring from a belief that the world revolves around us? Apparently not. Yet evidence abounds. Part the curtains of society's racial, ethnic, religious, national, and cultural conflicts, and you find the human ego turning the knobs and pulling the levers. Now imagine a world in which everyone, but especially people with power and influence, holds an expanded view of our place in the cosmos. With that perspective, our problems would shrink or never arise at all, and we could celebrate our earthly differences while shunning the behavior of our predecessors who slaughtered one another because of them. Back in January 2000, the newly rebuilt Hayden Planetarium in New York City featured a space show titled Passport to the Universe, which took visitors on a virtual zoom from the planetarium out to the edge of the cosmos. En route, the audience viewed Earth, and then the solar system, then watched the 100 billion stars of the Milky Way galaxy shrink, in turn, to barely visible dots on the planetarium's dome. Within a month of opening day, I received a letter from an Ivy League professor of psychology, whose expertise was in things that make people feel insignificant. I never knew one could specialize in such a field. He wanted to administer a before and after questionnaire to visitors, assessing the depth of their depression after viewing the show. Passport to the Universe, he wrote, elicited the most dramatic feelings of smallness and insignificance he had ever experienced. How could that be? Every time I see the space show, and others we've produced, I feel alive and spirited and connected. I also feel large, knowing that the goings-on within the 3-pound human brain are what enabled us to figure out our place in the universe. Allow me to suggest that it's the professor, not I, who has misread nature. His ego was unjustifiably big to begin with, inflated by delusions of significance and fed by cultural assumptions that human beings are more important than everything else in the universe. In all fairness to the fellow, powerful forces in society leave most of us susceptible, as was I, until the day I learned in biology class that more bacteria live and work in 1 centimeter of my colon than the number of people who have ever existed in the world. That kind of information makes you think twice about who or what is actually in charge. From that day on, I began to think of people not as masters of space and time, but as participants in a great cosmic chain of being, with a direct genetic link across species, both living and extinct, extending back nearly 4 billion years to the earliest single-celled organisms on Earth. I know what you're thinking. We're smarter than bacteria. No doubt about it, we're smarter than every other living creature that ever ran, crawled, or slithered on Earth. But how smart is that? We cook our food. We compose poetry and music. We do art and science. We're good at math. Even if you're bad at math, you're probably much better at it than the smartest chimpanzee, whose genetic identity varies in only trifling ways from ours. Try as they might, primatologists will never get a chimpanzee to do long division or trigonometry. If small genetic differences between us and our fellow apes account for what appears to be a vast difference in intelligence, then maybe that difference in intelligence is not so vast after all. Imagine a life form whose brain power is to ours as ours is to a chimpanzee's. To such a species, our highest mental achievements would be trivial. Their toddlers, instead of learning their ABCs on Sesame Street, would learn multivariable calculus on Boolean Boulevard. Our most complex theorems, our deepest philosophies, the cherished works of our most creative artists would be projects their school kids brought home for mom and dad to display on the refrigerator door with a magnet. These creatures would study Stephen Hawking, who occupies the same endowed professorship once held by Isaac Newton at the University of Cambridge, because he's slightly more clever than other humans. Why? He can do theoretical astrophysics and other rudimentary calculations in his head, like their little Timmy, who just came home from alien preschool. If a huge genetic gap separated us from our closest relative in the animal kingdom, we could justifiably celebrate our brilliance. We might be entitled to walk around thinking we're distant and distinct from our fellow creatures. But no such gap exists. Instead, we are one with the rest of nature, fitting neither above nor below, but within. Need more ego softeners? Simple comparisons of quantity, size, and scale do the job well. Take water. It's simple, common, and vital. There are more molecules of water in a cup of the stuff than there are cups of water in all the world's oceans. Every cup that passes through a single person and eventually rejoins the world's water supply holds enough molecules to mix 1,500 of them into every other cup of water in the world. No way around it. Some of the water you just drank passed through the kidneys of Socrates, Genghis Khan, and Joan of Arc. How about air? Also vital. A single breathful draws in more air molecules than there are breathfuls of air in Earth's entire atmosphere. That means some of the air you just breathed passed through the lungs of Napoleon, Beethoven, Lincoln, and Billy the Kid. Time to get cosmic. There are more stars in the universe than grains of sand on any beach. More stars than seconds have passed since Earth formed. More stars than words and sounds ever uttered by all the humans who ever lived. Want a sweeping view of the past? Our unfolding cosmic perspective takes you there. Light takes time to reach Earth's observatories from the depths of space, and so you see objects and phenomena not as they are, but as they once were, back almost to the beginning of time itself. Within that horizon of reckoning, cosmic evolution unfolds continuously, in full view. Want to know what we're made of? Again, the cosmic perspective offers a bigger answer than you might expect. The chemical elements of the universe are forged in the fires of high-mass stars that end their lives in titanic explosions, enriching their host galaxies with the chemical arsenal of life as we know it. The result? The four most common chemically active elements in the universe, hydrogen, oxygen, carbon, and nitrogen, are the four most common elements of life on Earth, with carbon serving as the foundation of biochemistry. We do not simply live in this universe. The universe lives within us. That being said, we may not even be of this Earth. Several separate lines of research, when considered together, have forced investigators to reassess who we think we are and where we think we came from. As we've already seen, when a large asteroid strikes a planet, the surrounding areas can recoil from the impact energy, catapulting rocks into space. From there, they can travel to and land on other planetary surfaces. Second, microorganisms can be hardy. Extremophiles on Earth can survive wide range of temperature, pressure, and radiation encountered during space travel. If the rocky ejecta from an impact hails from a planet with life, then microscopic fauna could have stowed away in the rock's nooks and crannies. Third, recent evidence suggests that shortly after the formation of our solar system, Mars was wet and perhaps fertile, even before Earth was. Collectively, these findings tell us it's conceivable that life began on Mars and later seeded life on Earth, a process known as panspermia. So all Earthlings might, just might, be descendants of Martians. Again and again, across the centuries, cosmic discoveries have demoted our self-image. Earth was once assumed to be astronomically unique, until astronomers learned that Earth is just another planet orbiting the Sun. Then we presumed the Sun was unique, until we learned that the countless stars of the night sky are suns themselves. Then we presumed our galaxy, the Milky Way, was the entire known universe, until we established that the countless fuzzy things in the sky are other galaxies, dotting the landscape of our known universe. Today, how easy it is to presume that one universe is all there is. Yet, emerging theories of modern cosmology, as well as the continually reaffirmed improbability that anything is unique, require that we remain open to the latest assault on our plea for distinctiveness, the multiverse. The cosmic perspective flows from fundamental knowledge, but it's more than about what you know. It's also about having the wisdom and insight to apply that knowledge to assessing our place in the universe. And its attributes are clear. The cosmic perspective comes from the frontiers of science, yet it is not solely the provenance of the scientist. It belongs to everyone. The cosmic perspective is humble. The cosmic perspective is spiritual, even redemptive, but not religious. The cosmic perspective enables us to grasp in the same thought the large and the small. The cosmic perspective opens our minds to extraordinary ideas, but does not leave them so open that our brains spill out, making us susceptible to believing anything we're told. The cosmic perspective opens our eyes to the universe, not as a benevolent cradle designed to nurture life, but as a cold, lonely, hazardous place, forcing us to reassess the value of all humans to one another. The cosmic perspective shows Earth to be a moat, but it's a precious moat, and for the moment, it's the only home we have. The cosmic perspective finds beauty in the images of planets, moons, stars, and nebulae, but also celebrates the laws of physics that shape them. The cosmic perspective enables us to see beyond our circumstances, allowing us to transcend the primal search for food, shelter, and a mate. The cosmic perspective reminds us that in space where there is no air, a flag will not wave, an indication that perhaps flag waving and space exploration do not mix. The cosmic perspective not only embraces our genetic kinship with all life on Earth, but also values our chemical kinship with any yet-to-be-discovered life in the universe, as well as our atomic kinship with the universe itself. At least once a week, if not once a day, we might each ponder what cosmic truths lie undiscovered before us, perhaps awaiting the arrival of a clever thinker, an ingenious experiment, or an innovative space mission to reveal them. We might further ponder how those discoveries may one day transform life on Earth. Absent such curiosity, we are no different from the provincial farmer who expresses no need to venture beyond the county line because his 40 acres meet all his needs. Yet if all our predecessors had felt that way, the farmer would instead be a cave dweller chasing down his dinner with a stick and a rock. During our brief stay on planet Earth, we owe ourselves and our descendants the opportunity to explore, in part because it's fun to do, but there's a far nobler reason. The day our knowledge of the cosmos ceases to expand, we risk regressing to the childish view that the universe figuratively and literally revolves around us. In that bleak world, arms-bearing, resource-hungry people and nations would be prone to act on their low, contracted prejudices. And that would be the last gasp of human enlightenment, until the rise of a visionary new culture that could once again embrace, rather than fear, the cosmic perspective. Whether you prefer to sprint, swim, walk, or crawl from one place to another on Earth, you can enjoy close-up views of our planet's unlimited supply of things to notice. You might see a vein of pink limestone on the wall of a canyon, a ladybug eating an aphid on the stem of a rose, a clamshell poking out from the sand. All you have to do is look. From the window of an ascending jetliner, those surface details rapidly disappear. No aphid appetizers, no curious clams. Reach cruising altitude around 7 miles up, and identifying major roadways becomes a challenge. Detail continues to vanish as you rise into space. From the window of the International Space Station, which orbits about 250 miles up, you might find Paris, London, New York, and Los Angeles in the daytime, but only because you learned where they are in geography class. At night, their sprawling cityscapes present an obvious glow. By day, contrary to common wisdom, you probably won't see the Great Pyramids at Giza, and you certainly won't see the Great Wall of China. Their obscurity is partly the result of having been made from the soil and stone of the surrounding landscape. And although the Great Wall is thousands of miles long, it's only about 20 feet wide, much narrower than the U.S. interstate highways you can barely see from a transcontinental jet. From orbit, with the unaided eye, you would have seen smoke plumes rising from the oil field fires in Kuwait at the end of the First Persian Gulf War in 1991, and smoke from the burning World Trade Center towers in New York City on September 11, 2001. You will also notice the green-brown boundaries between swaths of irrigated and arid land. Beyond that short list, there's not much else made by humans that's identifiable from hundreds of miles up in the sky. You can see plenty of natural scenery, though, including hurricanes in the Gulf of Mexico, ice flows in the North Atlantic, and volcanic eruptions wherever they occur. From the moon, 250,000 miles away, New York, Paris, and the rest of Earth's urban glitter doesn't even show up as a twinkle. But from your lunar vantage, you can still watch major weather fronts move across the planet. From Mars, at its closest, some 35 million miles away, massive snow-capped mountain chains and the edges of Earth's continents would be visible through a large backyard telescope. Travel out to Neptune, 3 billion miles away, just down the block on a cosmic scale, and the sun itself becomes 1,000 times dimmer, now occupying 1,000th the area on the daytime sky that it occupies when seen from Earth. And what of Earth itself? It's a speck, no brighter than a dim star, all but lost in the glare of the sun. A celebrated photograph taken in 1990 from just beyond Neptune's orbit by the Voyager 1 spacecraft shows just how underwhelming Earth looks from deep space. A pale blue dot, as the American astrophysicist Carl Sagan called it. And that's generous. Without the help of a caption, you might not even know it's there. What would happen if some big-brained aliens from the great beyond scanned the skies with their naturally superb visual organs, further aided by alien state-of-the-art optical accessories? What visible features of planet Earth might they detect? Blueness would be first and foremost. Water covers more than 2/3 of Earth's surface. The Pacific Ocean alone spans nearly an entire side of the planet. Any beings with enough equipment and expertise to detect our planet's color would surely infer the presence of water, the third most abundant molecule in the universe. If the resolution of their equipment were high enough, the aliens would see more than just a pale blue dot. They would see intricate coastlines, too, strongly suggesting that the water is liquid. And smart aliens would surely know that if a planet has liquid water, then the planet's temperature and atmospheric pressure fall within a well-determined range. Earth's distinctive polar ice caps, which grow and shrink from the seasonal temperature variations, could also be seen using visible light. So could our planet's 24-hour rotation, because recognizable landmasses rotate into view at predictable intervals of time. The aliens would also see major weather systems come and go. With careful study, they could readily distinguish features related to clouds in the atmosphere from features related to the surface of Earth itself. Time for a reality check. The nearest exoplanet, the nearest planet in orbit around a star that is not the Sun, can be found in our neighbor star system, Alpha Centauri, about 4 light-years from us and visible mostly from our southern hemisphere. Most of the cataloged exoplanets lie from dozens up to hundreds of light-years away. Earth's brightness is less than 1/billionth that of the Sun, and our planet's proximity to the Sun would make it extremely hard for anybody to see Earth directly with a visible light telescope. It's like trying to detect the light of a firefly in the vicinity of a Hollywood searchlight. So if aliens have found us, they are likely looking in wavelengths other than visible light, like infrared, where our brightness relative to the Sun is a bit better than invisible light. Or else, their engineers are adapting some other strategy altogether. Maybe they're doing what some of our own planet hunters typically do, monitoring stars to see if they jiggle at regular intervals. A star's periodic jiggle betrays the existence of an orbiting planet that may be too dim to see directly. Contrary to what most people suppose, a planet does not orbit its host star. Instead, both the planet and its host star revolve around their common center of mass. The more massive the planet, the larger the star's response must be, and the more measurable the jiggle gets when you analyze the star's light. Unfortunately for planet-hunting aliens, Earth is puny, so the sun barely budges, which would further challenge alien engineers. NASA's Kepler telescope, designed and tuned to discover Earth-like planets around sun-like stars, invoked yet another method of detection, mightily adding to the exoplanet catalog. Kepler searched for stars whose total brightness dropped slightly and at regular intervals. In these cases, Kepler's line of sight is just right to see a star get dimmer by a tiny fraction due to one of its own planets crossing directly in front of the host star. With this method, you can't see the planet itself. You can't even see any features on the star's surface. Kepler simply tracked changes in a star's total light, but added thousands of exoplanets to the catalog, including hundreds of multi-planet star systems. From these data, you also learned the size of the exoplanet, its orbital period, and its orbital distance from the host star. You can always make an educated inference on the planet's mass. If you're wondering, when Earth passes in front of the Sun, which is always happening for some line of sight in the galaxy, we block 1/10,000th of the Sun's surface, thereby briefly dimming the Sun's total light by 1/10,000th of its normal brightness. Fine as it goes. They'll discover that Earth exists, but learn nothing about happenings on Earth's surface. Radio waves and microwaves might work. Maybe our eavesdropping aliens have something like the 500-meter radio telescope in the Guizhou province of China. If they do, and if they tune to the right frequencies, they'll certainly notice Earth, or rather, they'll notice our modern civilization as one of the most luminous sources in the sky. Consider everything we've got that generates radio waves and microwaves. Not only traditional radio itself, but also broadcast television, mobile phones, microwave ovens, garage door openers, car door unlockers, commercial radar, military radar, and communication satellites. We're ablaze in long-frequency waves. Spectacular evidence that something unusual is going on here. Because in their natural state, small rocky planets emit hardly any radio waves at all. So if those alien eavesdroppers turn their own version of a radio telescope in our direction, they might infer that our planet hosts technology. One complication, though, other interpretations are possible. Maybe they wouldn't be able to distinguish Earth signals from those of the larger planets in our solar system, all of which are sizable sources of radio waves, especially Jupiter. Maybe they think we were a new kind of odd radio-intensive planet. Maybe they wouldn't be able to distinguish Earth's radio emissions from those of the Sun, forcing them to conclude that the Sun is a new kind of odd radio-intensive star. Astrophysicists right here on Earth at the University of Cambridge in England were similarly stumped back in 1967. While surveying the skies with a radio telescope for any source of strong radio waves, Anthony Hewish and his team discovered something extremely odd. An object pulsing at precise repeating intervals of slightly more than a second. Jocelyn Bell, a graduate student of Hewish's at the time, was the first to notice it. Soon, Bell's colleagues established that the pulses came from a great distance. The thought that the signal was technological, another culture beaming evidence of its activities across space, was irresistible. As Bell recounts, we had no proof that it was an entirely natural radio emission. Here was I trying to get a PhD out of a new technique, and some silly lot of little green men had to choose my aerial and my frequency to communicate with us. Within a few days, however, she discovered other repeating signals coming from other places in our Milky Way galaxy. Bell and her associates realized they'd discovered a new class of cosmic object, a star made entirely of neutrons that pulses with radio waves for every rotation it executes. Hewish and Bell sensibly named them pulsars. Turns out, intercepting radio waves isn't the only way to be snoopy. There's also cosmochemistry. The chemical analysis of planetary atmospheres has become a lively field of modern astrophysics. As you might guess, cosmochemistry depends on spectroscopy, the analysis of light by means of a spectrometer. By exploiting the tools and tactics of spectroscopists, cosmochemists can infer the presence of life on an exoplanet, regardless of whether that life has sentience, intelligence, or technology. The method works because every element, every molecule, no matter where it exists in the universe, absorbs, emits, reflects, and scatters light in a unique way. And, as already discussed, pass that light through a spectrometer and you'll find features that can rightly be called chemical fingerprints. The most visible fingerprints are made by the chemicals most excited by the pressure and temperature of their environment. Planetary atmospheres are rich with such features, and if a planet is teeming with flora and fauna, its atmosphere will be rich with biomarkers, spectral evidence of life, whether biogenic, produced by any or all life forms, anthropogenic, produced by the widespread species Homo sapiens, or technogenic, produced only by technology. Such rampant evidence will be hard to conceal. Unless they happen to be born with built-in spectroscopic sensors, our space-snooping aliens would need to build a spectrometer to read our fingerprints. But above all, Earth would have to cross in front of the Sun or some other source, permitting light to pass through our atmosphere and continue on to the aliens. We Earthlings already know the significance of our planet's distinctive chemical fingerprints, but distant aliens who come upon us will have to interpret their findings and test their assumptions. Must the periodic appearance of sodium be technogenic? Free oxygen is surely biogenic. How about methane? It too is chemically unstable. And yes, some of it is anthropogenic. But as we've seen, methane has non-living agents as well. If all the aliens decide that Earth's chemical features are sure evidence of life, maybe they'll wonder if the life is intelligent. Presumably the aliens communicate with one another, and perhaps they'll presume that other intelligent life forms communicate too. Maybe that's when they'll decide to eavesdrop on Earth with their radio telescopes to see what part of the electromagnetic spectrum its inhabitants have mastered. So, whether the aliens explore with chemistry or with radio waves, they might come to the same conclusion. A planet where there's advanced technology must be populated with intelligent life forms who may occupy themselves discovering how the universe works and how to apply its laws for personal or public gain. Looking more closely at Earth's atmospheric fingerprints, human biomarkers will also include sulfuric, carbonic, and nitric acids and other components of smog from the burning of fossil fuels. If the curious aliens happen to be socially, culturally, and technologically more advanced than we are, then they will surely interpret these biomarkers as convincing evidence for the absence of intelligent life on Earth. The first exoplanet was discovered in 1995, and as of this writing, the tally is rising through 3,000, most found in a small pocket of the Milky Way around the solar system. So there's plenty more where they came from. After all, our galaxy contains more than 100 billion stars, and the known universe harbors some 100 billion galaxies. Our search for life in the universe drives the search for exoplanets, some of which resemble Earth. Not in detail, of course, but in overall properties. Latest estimates, extrapolating from the current catalogs, suggest as many as 40 billion Earth-like planets in the Milky Way alone. Those are the planets our descendants might want to visit someday. By choice, if not by necessity.